Hey, okay guys, good news. I'm feeling quite relieved. I didn't think the answer would be that simple. But in our last video, you gotta watch the last video in order to know what the heck I'm talking about here. I was having problems picking up the, well, I think you would call them transient frequencies, because my extension cords and stuff going wrapped around the frame, and my antenna wire is coming around the frame, so it was picking that up. So the ground is the white wire and that black one is, I just used a coaxial cable. It just came to me to try it. I'm like, well, that's already got shielding on the outside. I'm like, I didn't think it would work, but it is. So, and here's the frequency now. Did that just change because I got near it? There's, it fluctuates a little bit. 300 kilohertz. Fluctuates a little bit. Kilohertz. Is it being affected by me a little bit? If I back off, it's going to go up to 300. Get a little close to it. I'm just close to my probes. Alright, so I'll have to watch things with that. But I like that, a nice round number there, 300 kilohertz. Inside the lab and outside the lab. Okay, now I'm gonna check the power readings again with my original circuit and the new circuit that I made in the last video with the Schottky diodes. I didn't get as much voltage out of them, but I was thinking maybe I'm getting more current, so I just want to check the power readings on those. We'll do that in a minute. Hang on tight. Okay, funny, the reason the reason that frequency drops when I get near it isn't because of me or my body. It's oh, Paul, it's because of my camera. The battery is low and I've got it plugged in right now. So when I go near it with my camera and the camera's got the cord, the power cord on it, it's changing it. I just went off camera here and I went near it and I'm like, it's not changing at all. So, alright, just had to let you know that. It's kind of funny. That's why you guys are experimenting with me. You see my crazy thought process. Alright, let's get back to checking those powers again here. Hang on one second. Okay, we got our original circuit in there. We're getting 6 1/4 volts out of it today with no load. Right now, here's with our LEDs, 21 LEDs on there. And we got 2.5 volts. Oh, I was actually got a little bit less current today, so I was able to use this. I've got this hooked up right now. As you can see, it fluctuates, but let's say 45 microamperes then times 2.5 volts, and that's with our 21 LEDs. And okay, so right now I'm going to mark them numbers down and try the other circuit with the Schottky diodes in it again. I'll be right back. Just wanted to show you real quick. I got this hooked up on there instead of the analog. I got the digital, and it is about the same. So I'm just gonna keep using this one because it's easier, and that one maxes, the other one maxes out at 50 microamperes, and I got bigger range on here, so I'm just gonna keep using this right now that I confirmed that, you know, I get the same readings. So okay, with that said, let me continue with the power readings on the other Scotty diode circuit. Okay, we've got our Scotty diode circuit hooked up here, and we got our LEDs hooked up. They're not even lighting up, the LEDs. When I first touch on there, the LEDs might light up for a split second, and that's it. Right now, with the load of the LEDs, I got 2¼ volts and 3 microamps. So I don't even have to do the math on that. Our other circuit was 6¼ volts with no load. With the load, it drops down to 2.5 volts and 45 microamps. Now, right now, we're at this circuit without any load is 2.8. With the load, it only drops to 2.3, but you only got 3 microamps. So with this number being lower and these numbers being lower, I could obviously see that the power with this circuit is much less. So we're gonna forget about those Scotty diode circuits altogether and stick to our original circuit now. I'll have to work these numbers and see how that compares to the other day when we had a 120 hertz going through my antenna. Let's see, this is from the other day. 2.5 volts top line. It was 60 microwatts then. $150 microwatts. Yeah, so we're not getting any more than that right now. 45. Yeah, so we could say roughly 150 microwatts is what we're getting. Okay, so that's it with the power for now. The next thing, let's see. Oh yeah, I got another design I want to try to replace this circuit. Cockcroft and Walton amplifier. I think to this day is actually still being used in particle accelerators. So I'm gonna try that design. And let's see, I still want to play around with this other penny circuit and these coils. I want to mess around with some coils, but first I think the next thing is this amplifier. Let's see if I could get a better one on there yet or not. So alright, I'm gonna go on and start soldering that amplifier together and putting that circuit together, and we'll be back. Okay guys, there it is, the Cockcroft Walton multiplier. It took me a long time to get that soldered together. There it is. Alright, so let's hook it up and see if we get better results than we've gotten from our other circuits. Alright, I'm excited about this one. We'll see what happens. Let me get it hooked up and we'll watch the results together. Give me a second here. Okay guys, there's our coaxial cable, our antenna, and that white wire, our ground wire, coming down to our circuit. There's our meter, and alright. Oh, I'm nervous. Alright, you guys are gonna see everything with me. There's the negative. And here's the positive. 15 volts. Okay. And I believe we can repeat this pattern out longer and get even more voltage. But alright, well, now the real question is when I add a load on there, how much is it gonna drop? And what our power is. Okay, so it looks good, but we'll see. In my other circuits, I'm only getting at the most 8 volts. This is doubled, but yeah, we'll see. Alright, let me think. I'm gonna try hooking on the 21 LEDs and see how much it drops. Give me a second.